right? So
Yes.
welcome to our talk on pursuing evasive custom command and control. We are co-presenting this talk. We'll be discussing and going through our agenda, which is we will discuss about cyber kill chain and the problem. We'll discuss about how can we improve and how can we defend or improve the security posture of our organization or the company we are working for. So we'll discuss about traditional command and control, OneDrive. Basically, we will also have some quick overview on how common command and control frameworks work. So we'll also introduce custom command and control C3. So it's made by F-Secure and MWR Labs. So we'll also discuss most of the common channels that are already out of the box in the C3. So we will also cover attack surface using command and control. We'll have a video demonstration on how it works and how you can track and see its behavior. So we'll also be covering a live demo on Splunk and detection strategies on how to detect custom command and control. And of course, lastly, we have a Q&A section as well. So who am I? I was already introduced. So my interest lies especially in red teaming and penetration testing. So you can call me Ian, you can call me Mark. I'm also working as a penetration tester in a law firm right now. So giving it to Renzon Cruz.
Yes. So again, my name is Renzon Cruz. So I was introduced already by Jami. So I normally work as a blue team guy and focuses more towards the FIR. And I love going to the conference. Sadly, we have COVID right now, but thankful to ROOTCON that they made it still possible through virtual meetups. So yeah, I like going to conference. I like going and hanging out with Jay, Docmon, and some other stuff. Um, and that's it. So we here presenting as Guidem again. So this is me and Ian. We co-founded this training provider in the Philippines to provide a real-world approach of having an offensive and as well as defensive disciplines of cybersecurity because we noticed that there's a lot of gaps in the Philippines talking about trainings. So we also do some services, but we're still at the early stage. And we provide highly technical and purely hands-on activities to our students and to our enrollees. And here are some of our gigs and also some media exposures throughout this year. Okay. And before we start, we need to discuss the lab setup that we have set up. So we actually have three labs set up, but I'm going to discuss first my home lab setup. So we're actually using Detection Lab. So shout out to Chris Long for providing this very great open source project. We have here like an enterprise level setup wherein we have a domain controller, we have a logger, we have Windows event collector, and also a Windows 10 where we can perform our adversary simulations. Um, so we have different sensors. We have network sensors like Bro, Zlog, Suricata. We have host logs wherein we utilize Sysmon. We also have Velociraptor for forensics thing, and also OS queries. So this is my home lab setup, which I'm going to show you later. Some Splunk, Foo, and some process chains that really make sense to discuss when talking about C2. And the other setup would be discussed by the next slide.
So for our next laboratory is we have this alternative laboratory, which is based on cloud. So we deployed it on AWS so that we can collaborate both on the offensive side and defensive side of cybersecurity discipline. We also use detection lab. So this one, we had an Elk, Elastic, Logstash, and Kibana for our SIM, just to have an alternative on what's the difference between how it can be detected on Elk or how you can query on Splunk. So that's why we have practical examples as well. So for our last laboratory setup, we have this one deployed in Azure. So we have this lab is originally from Defensive Origins and Black Hills InfoSec. So credits to Kent and uh, Rev for setting this one up. So you can set this one up in like 25 minutes. So it's a Terraform deployment script that basically you will have an environment wherein there is verbose logging, there is already Sysmon configured, and you have here help by CyberWar. This one, we integrated also our custom machines for the attackers, such as Covenant, C2, Empire, and Starkiller. We also have here C3 by F-Secure as well.
So now, the question is, why do we care? Why are we providing this kind of research as well as presentations to everyone? Because we noticed that a lot of APTs, a lot of attackers right now are leveraging command and control, which is given already, but they're blending in the noise and they're using different web services, cloud providers, as well as some applications that was used commonly, heavily commonly used on the enterprise level, such as Slack, Twitter, um, Gmail, Office 365, etc., etc. And this has been for a while. It's not really a new thing, but talking about different SOC professionals, security professionals out there, if we talk about how to detect C2, they just leverage the threat intel feeds that they have on their enterprise. But how can we perform like hunting, and um, how can we analyze the deviation between the normal and the evilness of those things? So that's why we have this talk. And the next one, so talking about the cyber kill chain, normally SOC just focus on people from external network that performs recon, weaponizations, and delivery. So as you can see on the slides, so the complexity of the color defines on how granular the attack is. So from the recon initial vector, so that's mostly SOC professionals are focusing on. But going into the deep side of the attack vector, like the post-compromise thing, command and control is on the second to the last of the kill chain, which is technically like a full control of your enterprise. Um, so they really just focus first on how to triage false positive alerts, as well as those things that are coming from external. But what if the attacker was able to gain his access like during weekend and leveraging a very rare misconfiguration? How can you detect? How can you perform hunting if they're performing command and control and leveraging your Slack channel, or your Office 365, or even your Gmail, or even your Twitter account? How can they just get your um, files and exfiltrate data from within?
So just a brief introduction on Command and Control 101. So there are many terms that we can define or we call Command and Control or C2. We can call it CNC and Command and Control Framework. So essentially, how we describe command and control is it's the way an attacker actually communicates to its victim machine or its compromised machine. So it may use different network protocols such as HTTP or HTTPS, most probably some leverage DNS and others as well. So we also have seen ICMP was reportedly being used to target organizations as well. So uh, we actually saw a lot of DNS traffic being leveraged by command and control channel because there's a lot of DNS traffic. It's too much noise and they can blend in to the traffic. So they can beacon or what we call heartbeat of the command and control. Basically, the beacon is just waiting for a command that will be issued by an attacker based on what's the objective of that instruction as well. So C2 or command and control hides in plain sight. So most of the times we currently see that the threat landscape nowadays when it comes to establishing command and control channels are the first objective is to blend with the noise, uh, look for the organization's applications that are being used, leverage them in order for them to blind perfectly or stealthily inside the network environment wherein defenders actually have a hard time on detecting these malicious activities. So uh, such as we have Outlook, we have seen APT groups use Twitter, Gmail, Slack, OneDrive as well. So the more benign, the better. So low and slow traffic usage. Most of the times, APT groups take advantage of um, having their traffic very low and using command and control only on times where they are mostly active users as well so that they can blend into the traffic. So basically, um, once communication is established between the victim, so the infected machine sends a signal to the attacker, and then the server will look for the instruction, and then they will basically be connected with each other, and then the attacker mostly will indicate other commands in order for him to actually gain more access or more foothold into the environment. So there are many ways, as we said earlier, to actually leverage different protocols. Some tend to be more stealthy than others, and sometimes they also leverage current exploits or 0 days. So they also tend to bypass existing and modify tools that are currently available as well. So traditional command and control communication is a user gets compromised, then the attacker establishes the command and control channel through the user's compromised machine. So once this bidirectional communication is already available to the attacker or the threat actor, the attacker will then issue out commands on demand on the compromised machines and send callback instructions as well. This is also known as a beacon.
So talking about mapping and what are the references or guidelines that we can leverage on how to detect and how to or how where can we read some references about C2? We well almost everyone right now is mapping their detections into MITRE framework or MITRE ATTN-CK. So we can see that we have 16 techniques even as of today. We have 16 techniques and some sub techniques on each part, wherein we can see what are the different types of the attacker, the APT, when they are using command and control. And talking about what we have discussed recently, so they keep on blending on the noise for them to be more stealthy and for them to do whatever they want, not being detected. So they leverage Telegram. So I was surprised that Spotify was also used as part of the C2 channel, Dropbox. So these are the web services. These are the applications that we normally use. We have like an enterprise account for this when we go to work. We also have a personal account for this when we're doing our personal thing. So it's really the question there is to how can we detect it? And so how some use cases here talking about Twitter on how they can use it. So bots use social media now for command and control. They've also used DGA for like domain name generation to do their malicious thing. And a lot of adversaries, I think I've seen the first report for Twitter as early as 2015. I'm not really sure, but it's not really a new thing now. It's not a new thing, but it's still being leveraged by the attacker. And here are some of the APTs that was provided by F-Secure that leverage the Twitter as a command and control channel. So we have Onion Duke. So these are like a Duke groups, Hammer Duke, Cozy Duke, and Mini Duke.
So we have here another channel that is being leveraged by APT groups. So gadolinium. So nation state activity group that has been compromising targets for nearly a decade. So they have optimized the use of OneDrive API and Office 365 as a C2. They leverage on creating an application on Azure and actually registering with certain permissions with regards to OneDrive API and leveraging it in order for them to use it as a command and control channel. So this type of technique is really useful as a lot of organizations actually use Office 365, OneDrive, and Outlook. It's because Microsoft infrastructure, sometimes a lot of organizations actually leverage a Microsoft powerhouse environment wherein it's very difficult to block organizations that are utilizing Office 365. But then again, it will rely on the policies and restrictions that you have for your users in order for them to actually conduct this campaign. So here we have an example of OneDrive being used as a command and control channel using Empire. So this is a typical example wherein the target actually depending on the delivery, most probably it's done via email. So we assume that Empire C2 is configured and then it can be integrated with Empire. They have an available listener and you can actually use it for your own experiment in order for you to actually improve your detection and know the behavior of this C2 channel. So, in order for an attacker or a threat actor to actually create a channel, so he will need to create an application and register with appropriate permissions on the Azure. So, set up Microsoft account permissions and obtain the auth code or authentication code, as well as the client ID and the tenant ID wherever it may apply. Also, the client secret as well. So, and then runs the listener. So, once an attacker successfully has these requirements, uh, we can see here an example of activity that is being utilized already by this command and control channel. So once the agent has been created and delivering the payload through email, it would be very trivial as the victim will be sending out unknowingly that his machine or her machine is compromised already. So once the user here we can see that the user actually executed the payload and then we used in this example Empire and Starkiller, which is from BC Security and Spectre Ops. So the attacker sends command through the C2 channel using OneDrive. So
Okay, so this is now on how we detect the C2, which is a common C2 of OneDrive. Again, why OneDrive? Why attacker leverage this? Because this is default installed on most common Windows systems. So we have here Well, let's go to map this on MITRE framework. So we have here T1059. So we call it technique ID. And T159 is related to a tactic called execution. And the technique is specifically called being command and scripting interpreter, which is PowerShell. So this is the technique when an attacker leverages PowerShell to execute. It can download, it can upload and run executables even from internet without touching the disk. So they call it in-memory attack. Um, so since Empire is also using a PowerShell to launch this attack, so we can detect most of this initial vector through investigating PowerShell events. So enabling 4103 as an event ID, the module script blocking, the transcript logging 4104 can capture those mechanisms of in-memory attack. So next, initially we said that we're using Sysmon. We really like Sysmon because it detects so much, and it's also customizable. So after we attack or after we perform the OneDrive C2 using Empire, we have here detections wherein we have an event ID 3, which is a network connection. So as you can see here that the PowerShell has an internet connections or network connectivity towards those specific IP. So this IP is actually from Azure. So this is an external IP that we are using, which we host our Kali Linux, which is the attacker's VM in Azure cloud. So checking the destination IP would be beneficial for you when you're detecting this kind of attack. So check it into your threat intel feeds if there's a matches and if there's any reports that has been submitted to that IP. And also event code 22, we love detecting DNS, especially when performing hunting. So when we go to Empire and the OneDrive.py, which is the Python script for the OneDrive module as a C2 channel for Empire, you can see on the code that they leverage PowerShell. And they also have the stage URL, which is their stager. So if this stager has been executed and then connect back to the C2 server that the attacker has, then we can see that it connects to the different API calls and the API DNS queries related to OneDrive. So we have here public.dm files onedrive.com, api.onedrive.com, etc. and etc. Okay, so event code one, this is related to process execution or process creation. So if you don't have Sysmon, then you're familiar with event ID 4688 talking into a Windows event logs language. This is the same thing on Sysmon. We can see here the PowerShell executions that has command line parameters that commonly used by the attacker. We have -nop, which means no profile. We have -sta, -w, Windows style hidden, -enc, which is really an interesting thing because they try to encode their commands as part of their obfuscation. So if you see like a bunch of base64 strings on a concurrent command line parameter, with the -enc, then that needs to be investigated further from the defender folks out there. And looking at the code specifically for the Empire with this OneDrive channel, you can see that the default launcher has a value of these command line parameters. So if you see on my query on my Splunk instance, I have here the parent command line with enc. So that's how we detect it. Talking on the host artifacts. Oops, sorry. Can you go up again, Ian? So that is the equivalent of the PowerShell events when we go to the Windows event logs that we have if we open up the transcript blocking, especially if you're using PowerShell v5, that gives you so much visibility of what's happening using the PowerShell. So you can see there that this is an event ID 4103, which is a module logging capability, and this is heavily used as well by Empire. Okay, so what we're talking recently is the beaconing. So if you notice something here, there is like a strange um, pattern of how the implants or the stager checks into the C2 server. So this is actually another dilemma of a defender because hunting the malicious beaconing traffic performed by the different attackers are really really hard, especially um, if you are monitoring a lot of endpoints. Like we're talking about here 10,000, 20,000 endpoints. How can you make sure that you are also monitoring the beaconing of those beaconing traffic? So this is the pattern that I'm telling you. Every 2 hours, as part of being stealthy of APT and different attackers group, adversary groups, they tend to not be more greedy. Like if I'm attacker, I'm going to push like a 1 gig of data in just 15 minutes. So that could be a red flag for a normal SOC environment. But if we make it like every 2 hours and then just a couple of megabytes of files that we try to exfiltrate, then that could be hard to detect. So um, we are now leveraging here the Zik logs, which is really powerful when we are performing a network security monitoring. So as you can see on the left side on the timing, so every 2 hours, there's a checking in interval of the C2, the attacker to the compromised machine. And you can see here the transaction ID is the same um, on the depending on the time. Okay, so this one is also interesting because we're talking about network forensics, which was leveraged by JA3. So shout out to Salesforce who created this kind of a very good framework. So JA3 is basically the concept of getting all the cryptographic exchanges and hashing it. So if you know about hashing or SHA some of the files like MD5, SHA1, SHA256, so this is basically the comparison of that into the network level. So what JA3 does is it is yeah, it just hash all those values from the SSL fields such as TLS versions, cipher extensions, and hash it into MD5 and then make a fingerprint of it. And then there are like 13,000, 15,000 or more out there that you can check if that fingerprint is malicious or if that fingerprint is just a normal activity from your environment. So when I check the JA3 capability of the Bro or the Zik that we have in our lab, I've noticed that the third one is actually pertaining to the PowerShell. So if you go to ja3year.com and slash form, if you check that, there will be a comment that this is actually a PowerShell. So this is like an empire connecting to its compromised machine through PowerShell.
So we also have Kaleido C2, which was developed by Chirag Salva. This one is a really interesting command and control channel. And as I may say, it's a modern type of C2 channel where it leverages Microsoft Graph as its gateway to actually issue out its communication. So the way an attacker or a threat actor can actually create this is as a red teamer, you can also create this by registering an application on Azure and setting up the proper permissions, which is for Microsoft Graph API. So here we has just set an example on basically a simple command and control channel utilizing and using Kaleido C2. So for as of the moment, Kaleido C2 supports uh, OneNote, Outlook, and Teams C2. So you can see on the screenshot on the left is that we have an Outlook command and control channel wherein the folder C2 is being used as a C2 channel. So a more clarity in this video demonstration as well, wherein we have on the left part is the victim, which is the Windows machine, and attacker C2. You can see here that we issue out the hostname command, and then momentarily there's some inputs on the C2 folder wherein um, it is being transported by or transmitted by the Kalido C2 uh, Outlook client as .exe. So in order for the communication to happen is it leverages the Microsoft Graph API. So here we can see we just added another user and just proof of concept to demonstrate that our execution is actually going through, not just by reading out its input and output.
And talking about the detections of what Ian has just presented is to checking as well the DNS of the DNS logs that you have and or the DNS traffic. So as he just said that this one is leveraging graphmicrosoft.com, which is the gateway of the data and the intelligence in the Microsoft O365 environment. So if there's any DNS queries getting into that domain would be a pointer of for your investigations in the future. Next is if you have like an unsigned binaries and then performing such commands like ipconfig, who am I, and also adding a user using a net use, that would be highly suspicious from the detection standpoint. So if I'm going to make like a detection query of this is that if there's like a weird binaries like an unsigned, which are we have here in the example down here, like outlook to client.exe, what else? Yeah, that's it. And having a command line parameters of this could be a highly value findings from detecting perspective.
So just to add to those statements by Renzon is we're in environments actually leverage the use of Office 365, Outlook, um, using Kalido C2 or using the Graph API as a command control channel can be difficult to detect if it blends in or conducts some process injections as well. So uh, that's it for the traditional and modern C2s that we actually have seen. So this one is our introduction to C3. So C3 is made by F-Secure and MWR Labs. So credits to these guys for actually creating this great tool that can help red teams and blue teams perform simulation exercises in order to effectively create detection engineering strategies and improve the security posture of the organization, maybe to check of which data sets are actually reporting and to simulate if these channels being used by threat actors can be detected on their environment. So C3 started as an external C2 implementation. Um, it actually leverages it actually acts as a gateway wherein you can actually extend the red team tooling into Cobalt Strike and Covenant. So um, this framework allows for red teams to develop their custom command and control channels quite easily uh, and can be used in order for detection as well. So we have here a diagram on how this works. So the attacker uses these channels and then C3 acts as a gateway wherein the gateway actually connects to the main node, which allows the other infrastructure around it, such as a C2. So the components are here. So we have a connector. The connector is the connection between gateway and the C2 framework. These components of C3 is much more clearer in the demonstration later. Um, so we also have the channel, which is a communication medium by default, we can use Slack or UNC Share, OneDrive. We can also optimize the use of G Drive and Dropbox as well. So the channels are developed by contributors also, and there are out of the box channels that we have used in order for this presentation as well. So relay, this is the payload of the C3. So the relay is an executable or a shell code that if executed to the victim, it will connect to the gateway, and then you can set up a relay in order for you to execute commands or perform the data exfiltration. So we have the C3 extensions as well. We have channel interface and implant interface. So this basically just implies that you can actually use one channel for input and one channel for output. That that's what they describe this framework as modular is uh, because you can actually I might say that the limitation is there is no really limitation on the path that you can create here because it's really extensive and modular. So we have here an example of a C3 channel optimizing Slack. So why Slack? So organizations are using Slack for their collaboration. So this is oftenly seen that APT groups has actually used this one. So we have the default C2 channel or the previous C2 channels developed such as Slack or Slack C2 bot and Slack shell. So uh, these ones are used as a standalone framework wherein C3 actually has its own Slack channel wherein you can actually do a lot more and integrate it with Covenant and Cobalt Strike or other C2 tools as well. So um, what we have here is a legitimate application that will try to blend in uh, on the traffic of the environment. And there is little risk that endpoint solutions or antivirus solutions can detect the infiltration of malicious code in the legitimate application. It uses as well API calls. So here is just an example of the traditional execution of a C2 wherein win underscore slack underscore implant.exe. So it's from Slacker, I think. So running who am I using Slack against the channel, it actually execute the code. So you can we provided also the reference link below for the using attack web services for MITRE as well. So here we demonstrate on a C3 channel wherein we created a Slack negotiation channel, and then on the left part we have a Slack channel open. So we have created here a relay wherein the relay once executed on the victim machine, it will actually be connect back to the gateway. So the requirement for this is to have a Slack API token with the proper permissions. So we didn't obfuscate the Slack token because it's not active anymore. So here you can see the actual execution of the exe, and then you can see that the execution is already happening, and the Slack channel has its gibberish inputs being deleted and used to actually communicate to the channel. So once this relay and channel is already set up, we have a way to actually integrate this into our command and control framework, wherein we just have to select a feature called turn on covenant and connect to our covenant or C2 infrastructure, wherein we can actually leverage more attacks. So here you can see that the API call from the C3 actually success and connected created a bridge wherein the C3 and our Covenant command and control is actually integrated with each other. After it, we issue out another a peripheral grant wherein it will send out a payload to the Slack channel, and then we can now finally have a grunt or wherein we have successful communication. So the purpose of showing Slack and Covenant side by side is that you can actually see the live demonstration on live execution, what's happening. So you can see that once the payload or the identifiers are already executed, it will then go through Slack and then it will get deleted immediately. It's basically input and output. So here we just issued more commands so that we can actually see that the Slack C2 channel has been created, and it actually inputs and outputs out uh, the necessary command and instructions for command and control. So here, we also have um, implied that sometimes it takes a while because you can actually set the delay and jitter on the gateway on the relays, which makes it more modular, wherein you can actually um, set this type of behavior depending on the environment. So in order for you to blend in. So here is just a summary of what has happened there. So in this part of the diagram, we actually had another victim connect back to the gateway and see if and observe the behavior. So later on, we will actually discuss how the detection part of it works. So right now, most of these are we have provided the evidence and some guidance on how to detect these types of activities in the environment. So next is we have a Dropbox C2 channel or C3 channel. So Dropbox has a rich and well-documented API. You can actually leverage it for command and control. So traditionally before we have Dropbox C2, uh, which is the first command. I think it was the first command and control for utilizing Dropbox. So once you have created an application on Dropbox, you create an API, and then you can actually extend it to the external C2 feature of Cobalt Strike and also on the C3 framework. So here is just a diagram showing the overview of the process. So once the file has been created on the Dropbox and the UUID or the unique identifier, it will poll Dropbox and then issue out commands. So Renz, can you
Yes, this is just the victim view. So me actually this is me performing or running the malicious binary that was created as an implant from C3. And running this, I can see in the task manager that it runs after running it on via command line. It also connects back to an external IP, checking on the network summary. I've also opened up the process monitor before running it, so I can see the behavior that it does once running it.
So here we have just the same demonstration actually utilizing and leveraging the command and control for Dropbox. So what we wanted to show here is that the execution for the command and control channel in Dropbox as well. So once the Dropbox channel works, it's basically the same way it behaves on the Slack channel as well. So the summary of this is we actually used Dropbox to exfiltrate. Later on, we will actually see how it looks like on the exfiltration. But in summary, we have here the exfiltrated data wherein it is actually on the C2 on the relay of the Dropbox. So another C3 channel is the UNC share. So C3 can use UNC path in order to move laterally on the network. So as you can see in the below, we have this identifier wherein C3 uses it to leverage communication via UNC path. So using the same Dropbox app, we can create this C3 channel wherein this is just a summary of the latter part, the earlier part wherein the channel actually executes to the folder. So what we see here is that the integration between the gateway and the relay are actually, you can see that we already know the computer name, host name, and then we can actually issue out exfiltration data as well. So let me just, so the next channel is the Google Drive. So we have here a use case on APT groups actually leverage the use of Google Drive. So Rogue Robin malware uses Google Drive as a C2 channel, wherein you can also use it on C3 as well. So we have here a creation of the Google Drive. So the same approach wherein just need the client ID, secret, and refresh token. So after this has been filled out, C3 actually creates a channel for us to use. So uh, once the execution happens, it will then have as the same C2 channel uh, actually integrated into the C3 framework wherein you can provide more flexibility.
So this is the victim where we perform or where we run the implant of the Google Drive coming from the C3. So as the same example before, so this is just the task manager, and also we enable the process monitor while running it, so we can see the behaviors of that. And this is just the attacker's view wherein Ian is performing a Google Drive channel custom and command and control channel via C3 and also Covenant. And here we are now talking about detections. So detections, when it comes to network tracing connections, that is kind of weird, especially from those unsigned binaries again. So here I have here a Splunk query of Sysmon event ID 3, wherein I have a binary that connects to our Azure, which is our attacker's IP. And also DNS query. So if you have like an unsigned binaries that performs a weird DNS query going or towards to your normal channel or a normal web applications that you are using in your enterprise, so that could be highly suspicious as well. So you can also detect that via event code 22 from Sysmon. Next. DNS. Okay, so this is actually a normal Slack network traffic. But again, check the source connecting to this one. That would help the SOC professionals or the defenders to check what are the deviations of that. And also one thing about this talk is to make sure that you can also enable the ETW. So what is ETW? This is the event tracing on Windows. So this is really an efficient kernel level tracing facility that lets you log the kernel or even the application define event to a log file. But again, remember that enabling ETW is too noisy, so it is commonly used for debugging an application. So this one is more of a post exploitation wherein the victim machine has executed the unsigned binaries from the C3, and then performing weird process command line parameters such as who am I, adding a net user, IP config all, and those things. So mapping into the MITRE framework, that's going to be a T1033. And event ID 22 is talking about DNS query again. So if that source IP is not really needs to connect to some API calls from the Dropbox or from Twitter, Gmail, Office 365, then that could start an investigation. Next is the Bro DNS again. So this is just an equivalent into Splunk. So next. And also connecting to these IPs from the implants that we have. So we're just showing to you on how you do that into your log aggregation such as Splunk. And this one is the different functions that was used by the C3 channel if they leverage the Dropbox as a custom command and control. So you can check all those activities towards to these URLs. Next. So this one is interesting because we've noticed that NTDLL.dll is can be a good point of all call trace, which is can lead into a process injection. So you can see here that we have here the implant as a target image, and then on the call trace it calls up the NTDL.dll. So the NTDL.dll is more of interface to a Windows kernel. And then one of the host artifacts that we have noticed as well is, especially if you're performing an Empire as your C2, you can also see some PowerShell events. But if the attacker was able to delete those logs from the PowerShell event logs perspective, then we can also see those PS transcripts in your Windows environment. So you can just go to this folder, PS transcripts, and you can see most of the command line parameters or the commands that was used or leveraged by the PowerShell. And this one, creation of accounts. So this is a part of a persistence mechanism of an attacker. So once they got the initial foothold, they'll just create different accounts or multiple accounts as their backdoor, so they can just connect back if ever their initial access has been revoked by security guys or from SOC. And this one is just the graphical process chains wherein we can see that we have here the count of the executions of these are very low. You can see that it's just one execution, one count, and then two counts. But it can lead to a domain compromise, or the whole entire enterprise can be compromised by these implants. So from cmd.exe, it calls or it executes different implants from the C3 channels that we have. And so this one is, we also perform a C3 channel using a GitHub, and we see the DNS queries that it calls to in different API DNS result names from GitHub. So now, how can we improve? So of course, we need to identify if we have the capability to detect it. Do we have enough data sources? Are we actually monitoring the network traffic? Are we monitoring the process executions of different command lines? If the DLL has been connecting into a different network, are we also getting that kind of data sources? So first is to just determine what data sources do you have, and then study and check what are the public resources or references that are available. And then from there, you can create or craft your detection engineering or detection strategies from that standpoint. And also leverage the usage of a MITRE framework, because everyone is tracking or mapping all of their detection queries, search queries, watch lists into a MITRE. So just an overview on how we detected this. We need to look for unknown protocols, but nowadays, as C3 has been introduced for us, it also uses known protocols like DNS over HTTPS, or ICMP as well can be used. So to look for a beaconing behavior, as we have said that those network connections, tracing network connections that connecting with an interval and having some jitter of it. So most of the C2 can customize those kind of configurations from their server. weird user agents. If you've seen something like Empire, PowerShell, Bits admin, so those are just living off the land binary digits that can appear into a user agent. So if they try to download something, then those are the binary digits that can be rarely seen doing that. Tools that we can recommend here. Rita is an open source, Freak.py, so it was created by a science instructor, Mark Baggett. I think that's his name. So it just see the stacking and can easily check from anomalies like if it's performing DGA or domain generations algorithm. GA3 from Salesforce. This is on how you perform SSL fingerprinting, so you can also use that. C2 Matrix, so it's a collaborations of a different people, but I think George is also one of the speaker of ROOTCON. He and Brian also made this project open for public, so you can reference what are the different C2 tools that we can use from the attack standpoint and study it from the defensive side. And that's it. We're done. Thank you guys for listening. So again, you can follow us on Twitter, LinkedIn, and also you can also like our page, follow us on Twitter, LinkedIn using our guidance page. And on behalf of Ian, again, once and for all, thank you so much for listening to us. And again, to RootCon Goons, thank you so much for having us here. So we are now opening up. If we still have time, we're sorry. I think we just extended few minutes here.
All right. No worries about that. We are actually flexible here in RootCon. So there is actually a question for you guys, and there's also an addition from Gagan Jatana. Gagan said that just to addition into the prevention public cloud storage can be blocked by the next generation firewalls. Example, Palo Alto. And then for you said that you started seeing Twitter C2 since 2015. Actually, C2 in Twitter has been um, long been seen since 2009. There's a presentation in RootCon about Twitter C2 since 2000. I think that was RootCon 2 or 3, wherein we had a
That's
presentation about
interesting.
Twitter. Yeah, C2 frameworks for using Twitter. And then we have a question here right now. Aside from detection, what proactive controls can you recommend to defend against C3?
Prevention side. So uh, checking the network traffic and also making sure that you have the visibility of what you're trying to detect, especially the ETW that I've discussed. Those DLL that connects into weird public IPs, external IPs that shouldn't be connecting. That would be a great value findings for me. Ian, can you add more to that context?
Also, I think for since we already are being forced to use cloud services, or rather it's very seen nowadays that most of the infrastructure are on cloud services. It's notable that we must apply proper access controls, or IAM, in order to secure our API keys, secure the installation of these malicious applications that are not from our organization.
Yeah, talking about access controls, also about the logging capability of these channels such as Microsoft Office 365. There's been a very great audit logging capability of this platform nowadays. So you can also check that out, or you can just get these logs, push out into your SIEM solutions, and then make aggregations on that.
All right. Any other questions? I think we've answered everything. Have we answered this question? Are there already automated technologies or tools that could detect and identify C2, C3 traffic from a normal one?
So as per Gagan, from Nobody guy, so he said that most of the next generation firewalls, such as Palo Alto, can detect this kind of malicious thing.
Mhm. And then can signed image like Chrome executable can be used to generate C2 traffic.
I would say yes. Um, so um, so yeah, it can be used to even PowerShell, like we've seen the C2 channels that just leverage PowerShell and then connect back to the GitHub repo where they hosted it. So having more visibility on your enterprise can detect the most interesting things out from the normal behavior.
All right. Sorry. I know we still have other questions to be answered, but I would encourage for you to touch base with our speakers directly, so there's more interaction happening. I trust that Renzon and Mark are already in Discord, right? So easiest way to reach them out is at Discord. Other ways of reaching to both of you, could you share them with us, please?
Yes, Ian, can you show the follow us slide?
Oh, sorry.
Yeah, that one. So we are on Twitter. So I'm Renzek and Ian Secretario. So you can just follow us, DM us, or you can also PM our page, which is a guidance training. So normally we answer common queries there.
All right. Mark, Renzon, thank you very much for, again, putting yourselves in front of the crowd, putting yourselves in the spot for this talk. We really appreciate the time, and we also appreciate the information that you have shared with us. Very, very helpful. I know for all our InfoSec buddies out there and professionals, they'd be able to take a look at this and have a try themselves, right?
Yep.
All right. So with that said, again, thank you. We'll ask you to drop off from being a
All right.
panelist for a
Thank
second.
you. Thank you
Thank you.
so
Thank
much,
Thank
you.
you.
guys.